So in this question, to solve as the first question, which is the length of the chord AB, we need to know, first of all, we have got two circles, circle 1 and circle 2. Now the radius of circle 1 is 8 centimeter, which means also this is also 8 centimeter. They have the same radius. Now the chord AB, to get the length of the chord AB, first of all we need to find AX, and what we have here is the length of OQ. Now the point X divides OQ into two equal halves. So if OQ is 12, then this is 6 and this is also 6. Now with triangle AOX, where OA is 8, OX is 6, we can get AX by using what we call Pythagoras theorem, because this is a right angle triangle. What you are finding is the height. Therefore height squared is the same as the hypotenuse squared minus the base squared. Height squared in this case is AX squared, the same as 8 squared minus 6 squared. This will likely give us 64 minus 36, which is the same as 28. AX will be the square root of 28, which will give us root 2 root 7 if we convert into third form. But what you're interested is AB. AB is twice of AX, and this gives us 2 multiplied by 2 root 7. This gives us 4 root 7. Okay, those of us who have not yet covered surds in form 3, we can directly convert this one into decimal. We just need to find the square root of 7 and multiply by 2. So AX is 5.29, and therefore AB will likely be twice of that. 5.29 times 2, which gives us 10.58 centimeter. Now to find the area of the shaded region, I want us to focus on a few things, and that is, if you look at this diagram, we have a quadrilateral AOQ. We have this quadrilateral here, AOQ, and then what is the quadrilateral made up of? The quadrilateral is made up of two triangles, that is triangle AOB and triangle ABQ. So for us to get the area of the shaded region, the area of the shaded region will be area of quadrilateral, and this quadrilateral is AOBQ, and then we subtract from the area of the oval part, and the oval part is the unshaded part. Okay, so the first thing we're going to do is find the area of the quadrilateral. The quadrilateral is made up of two triangles, and the two triangles are triangle AOB and triangle ABQ. So what we need to find is that these two triangles have got the same base and height, because they've got the same radius. The circle has got the same radius. So what I need to find is only triangle of the area of triangle AOB, and then multiply by 2. So what we calculated in part A was the length of the chord AB. The chord AB happens to be the base of the triangle, and the height of the triangle happens to be OX. Therefore OX is the height of the triangle. So if you want to find the area of a triangle, the formula is a half multiplied by base multiplied by height. So this will give us a half multiplied by the base, which is 10.58 as we calculated in part A, multiplied by the height, which is 6. Simplifying further, this will give us the area of one triangle AOB as 10.58 multiplied by 3. That gives us 31.74, and since the quadrilateral is made up of two triangles which are of the same area, we can just multiply by 2. Therefore, the area of the quadrilateral is 63.48 centimeter squared. So we've come to area of the oval part, which is the unshaded region. And for us to find the area of the oval part, we need to subtract the area of sector minus area of triangle. We going to use the formula theta over 360 times pi r squared minus, and of course the area of a triangle is a half base times height. So which is the sector in this case? So the sector here is this region, because we have got two sectors here, because since we have two circles, we have two sector. This sector for circle 1, and then we have got another sector for circle 2. Both sectors are same. Since we have got two circles which have same radius, we can say that the area of both sectors will be the same. So what we need to do is we find the area of one sector minus the area of one triangle, and then subtract, then multiply by 2 to get the area of the oval part. So how do we get theta? Now if you look at this triangle here, we said this is 6 and this is 8. What we need to find is only this angle, then multiply by 2 to get angle AOB. So we are going to use what we call SOHCAHTOA. That is the trigonometric ratio cosine, which stands for us to get the cosine of theta. Cos theta is the adjacent side to that angle theta over the hypotenuse side. So the adjacent side, that is the side close to this angle, is side OX, which is 6 centimeter, divided by the hypotenuse, which is still 8. Okay, now to find theta, we'll find cos inverse of 6 over 8. Using calculator, our theta will be 41.441. But then we are looking for angle AOB, which is twice of this, and that gives us 82.82. Now with that, we can be able to find the area of the sector. So we just need to substitute theta with 82. So we'll have 82.82 divided by 360 multiplied by 22 over 7 times 8 squared, which is the radius, then minus a half multiplied by, remember the base of this triangle is AB, chord AB, we calculated in part A, and that is 10.58 multiplied by the height 6, which is OX. That is for triangle AOB. So here we're going to have 46.27 minus 31.74. That gives us 14.53. That is the area of the oval part. But our question was about the area of the shaded region, and if you remember very well, when I started calculating the area of the shaded region, I said it is the area of the entire quadrilateral AOBQ minus the area of the oval part. So if anyone remembers, the area of the shaded region is the same as the area of the quadrilateral. In this case, we got 63.48 minus the area of the oval part. Remember, this is the area of one side of the oval part, which is this side. Okay, and then there's another side also, which is this one. And since these two circles, they have same radius, they have got the same area. So 14.43 is not the area of one oval part. The oval part has two sides, this the right side and the left side. So 14.53 we calculated is this right side, and since they have got same radius, the two circles, again the area of also the oval part on the left side is still the same. So we need to multiply by 2 here, and this will give us 29.06. This will be the area of the oval part in total. So that is 29.06. This gives us 34.42 centimeter squared. That happens to be the area of the shaded region. It's a bit tricky and a bit lengthy. I will urge you to pause the video every time, replay again, and if you have an extra question, you can always put in the comment section. I will be explaining very well.